Welcome back to your favorite fundamentals of college algebra class. We'll take a look college fundamentals college math class. Gonna take a look at data today, okay? And just to start out, when we're categorical or qualitative data, just allow us to classify the objects into various categories, right? Categorical is usually non-numeric, like eye color, political party affiliation. But we can begin working with categorical data by summarizing it in a frequency table. So with a frequency table, what's that? Well, that's shown down here below. You have two columns. One column lists the values of variables, the other one the corresponding frequency or how many items in the category. Okay, sometimes you have a third column, which we'll talk about. So let's look at this first example. We've got this insurance company, and that's determining insurance premiums based on known risk factors. If a person is considered a higher risk, their premiums will be higher. One potential factor is the color of your car. And so here's the data that they have summarized. Okay, so let's put it into our frequency table. So it looks like the color blue from the data, it looks like there's 25 people with 25 people with a blue car. It looks like we have 52 with a green car. Why does it keep doing that? We have 41 with a red. We have 36 with a white car. We have 39 with a black car, and 23 with a gray car. Now, if we were to add all these up, 25, 52, 40, add those all up, looks like we get 216. So what would our relative frequency be? Well, 25 out of 216 people have a blue car. So 0.1157 or 11.57%. All right, so let's go ahead and just put in our relative frequency. Same thing for all these, 52 out of 216. And you could fill this whole thing in. And there's the rest of them to fill in the relative frequency as well. So that's a frequency table. Now let's talk about bar graphs. Here is a graphical display of your data that with the length of each bar indicating the frequency. All right. So let's do that same data here. Now we know we have 25 cars, so we're going to go up to 25. There's the green. We have 52, so we're going to go clear up here to 51, 2, about right there. 52. And if you want, you can actually put the frequency at the top of that as well, at the top of each bar. Red, we got 41. And so on. And there's the rest of them for our bar graph. Now let's go ahead and let's see if we can read a bar graph. Bar graph below represents the frequency of eye color in a class of students. So how many students have hazel eyes? It looks like hazel eyes looks like it hits right there at 4, right? So we got 4 of them with hazel eyes. What color is the most frequent? Well, what's the highest one there? It looks like it's brown. Right? Brown's the most frequent. Least frequent looks like it's gray. Looks like there's one with gray. How many students are in the class? How many students are in the class? Looks like I got 2 plus 6 plus 13 plus 4 plus 2 plus 1. So it looks like there's 28 in the class. What percentage of the class has blue eyes? Well, it looks like there's 6 with blue, so 6 out of 28 total students would give us 0.2142857 143. So about 21.43 if we round to the nearest hundredth. All right, so we've had frequency chart, we've had a bar chart, right? And now we've got a bar graph. Now we've got this is called a Pareto chart. So this is a Pareto chart, is just a bar graph, but it's ordered from highest to lowest frequency. So you notice with those car data, now it's we're listing the green first because we have 52 of those, down to the least 23 with had a gray car. All right, so that's a Pareto chart. A pie chart is where we put it into a circle, and then all of the wedges add up to 100% of the pie, right? So let's use our relative frequency from the pie chart to create a pie chart or a circle graph. Also, same thing. So I'm going to do my best. Hey, look at that circle. I found a new trick on this thing. I'm going to actually start with my largest amount. It looks like green is 24.07%. So that's about a fourth, right? A fourth of my thing would be 25%. So I'm going to do my best to do not quite a fourth, but here's my green. I got 52 of these. In other words, 24.07% of the people had a green car. My next biggest is going to be my red, 18.98%. So let me do red. Oops. Well, there's 41 of those. Oops. 41 of those are 18.98%. And then, what was it, black? So I pick up black at 18.06%. 39 of those. And then looks like white. Let me do white and orange. So white, I've got 36 of those, 16.67%. And then I'll go with the blue, 11.57%. And my last one's a gray. I'll just do it in blue again. So gray, 10.65% there. Now we have a pie chart showing all the percentages. And you notice all the percentages will add up to 100%. Let's go ahead and read this pie chart here. It says Logan categorizes spending for this month in 4 categories. You see the percentages there in that pie chart, right? If Logan spent a total of $2,400 this month, how much did he spend on food? Well, he spent $2,400 total. How much was food? Food was only 23%, right? So I'm really figuring out what's 23% of $2,400, right? So let's just multiply that. 2,400 times 0.23, 23%. And you get $552 was spent in the category of food. Now, what you want to keep in mind with data, visualizations, distortions, deceptions, you want to be clear and transparent. You don't need to get all fancy. You want to be clear and transparent with your data. For example, this 3-dimensional bar chart shown below, it's really not as effective as just a straightforward 2-dimensional counterpart. So again, just the idea is to be clear and transparent. How else can you get distortive or misleading with your visualization? Well, look at the bottom number. You want to be consistent with this. right? So if you look at the one on the left, right, these are both showing the same data, right? There are two graphs. There are people showing support for same-sex marriage or opposing it, taken from a poll in December 2008. And on the left, notice we're starting at 0, right, and we're going up by 10. You should go up the same amount each time, right? But over here, it's just showing you, well, it's having it start at 40, right? There's, the left-hand side is your clear and transparent data, right? There's not a ton of difference there. The right-hand side is like, man, that sure looks like twice as many people oppose same-sex marriage as those that support it, right? It's distortive of the actual data because it's really emphasizing that difference there because you're not starting at 0 on the bottom. All right, now we're going to look at presenting quantitative data graphically. Okay, so quantitative or numerical can be summarized in frequency tables. So let's go back to this frequency table. Now, it might be kind of hard to look at here, but a teacher records all these scores for these 30 students. We're going to put the score, and the frequency of that score. So, for example, it looks like there's 2 people that scored a 0. I think those are our only 2 right there. The next highest looks like it's a 5. Right next to it there. I wish this was in order, but it's not. So 5. There's one person that scored a 5. The next is a 12. And there's just one person that scored a 12. Next highest is 15. Let's see, there's a 15. There's a 15. So it looks like there's 2 15s. And I'm going to continue on with this and pause the video. So here's our frequency table. If you notice that this total adds up, so there's 30 total students in there, right? So there's 30 total numbers there. Now you might be thinking, could you create a bar chart of this? Well, it's kind of awkward. This is the frequency. 0 has 2, 5, the next to 5, we had 1, so on. But, this bar graph doesn't really make sense because the, first and second numbers, these are 5 values apart. It's just kind of awkward, right? And they're both numeric, both the category and the frequency there. So it would be more correct to use what's called a histogram. So what is a histogram? It's like a bar graph, but your horizontal axis is a number line. Okay, that's the difference with a histogram. The vertical axis still represents frequency. So for this data, what you would do, you still got your frequency over here, 1, 2, 3, 4, 5, 6, 7, 8. And let's start out with 0. There's 20. And that left-hand side, I'm going to go with that left-hand side. So 0 up until, but less than 1, right? This is 0, then 1. Let me erase that right there. So on. We had 2. And then at 5, so the left-hand side of the bar, 5, we only had 1 of these. And then it jumps to 12. I had 1. 13, 14, 15, we had 2. and so on. Anyways, I got a nice picture of it right here. I'll show you right there. You can see that histogram right there, right? Now, some people do choose to put the bars at half values to avoid the ambiguity instead of on the left-hand side of it, and that's what's showing it down below. See how the zero's in the middle there, the 5's right in the middle there, the 12's right in the middle of the bar right there, and so on. So you could choose to do it that way if you'd like as well. Sometimes you can have too big of a frequency table, right? If we have every possible value as a category. And so what you can do is you can group the data into intervals, right? Just make sure you're consistent with the sizes of those. So suppose in this example, we have collected weights from 100 male subjects. Use the frequency table to answer the following questions. Number one, can we draw a histogram of the data? Sure, so we could go from 120, so we'll start here at 120, up till less than 135. We have 4. Let me go by 5, 10, 15, 20, 25, 30. So we have 4. And then from 135 to 149, we have 14. I'm going to pause it as I create this. All right, very tedious, but we did draw the histogram. And I did write the frequencies at the top of those. Part B, how many men had weights between 195 and 209? 195 and 209. It looks like there were 8 of those. 8. How many men had weights that were at least 225? At least 225. So 225 or more. So 6 plus 2 plus 3. 11. So 11 men that were at least 225 pounds. What percent of men weighed less than 150 pounds? Well, it looks like less than 150. Less than 150, that'd be the 4 and the 14. Well, there it is on the frequency table. So there's 18. 18 out of, now the total, how many are, there's 100 of these, right? If I was totaling this up, you'd see there's 100 of these male subjects. So 18 out of 100, or 18% weighed less than 150 pounds. Well, now that we've learned how to display data graphically, let's talk about the characteristics of the variable's distribution. So the distribution of a variable tells you all possible values the variable can take on and the frequency that each of the possible values occurs. Okay. In the last section, we talked about these frequency tables and histograms. Those are 2 ways that shows a variable's distribution. We can also do that with smooth fitting curves. So we're going to, in stats, we're going to look at the shape, we're going to look at the outliers, the center, and the spread. We're going to do measurements of all these: shape, outliers, centers, and spread. Okay? So let's talk about shape for a minute here. If you had this histogram down below and you kind of tried to connect that a little bit, you see the nice smooth curve here, right? That's kind of showing you the shape or the distribution of the data. And there's different types of distribution, different types of shape. So the most common one is what's called a bell curve. This is when a normal distribution is referred to as a bell curve. So when it's symmetric, right? The left-hand side, see how if I split that, the left-hand side is equal to the right-hand side. That's a bell-shaped or normal a normal distribution. Okay, same thing over here. This is a normal distribution. If you split it, it's like a mirror image on both sides there. Okay, you can also have skewed data, and the way they name this is how does it tail off? If it tails off, if it peters off to the right, see how it peters off that way? It's right skewed. If the left-hand side is petering out, if you will, it's left skewed. Let's look at some distributions with a histogram. So the histogram below here shows the model year for a sample of 40 vehicles. Is the distribution symmetric or skewed? So if I was trying to draw this, it'd kind of be like that, right? Can you see how it's kind of petering out to the left? So this is like left skewed. It is not symmetric. Right? It's not even on both sides. This is left skewed. Let's look at this one here. This one's a little bit more, if I was trying to draw this as best I could, this is a little bit more normal or symmetric, right? It's about the same on both sides. So this is symmetric, normal distribution. In other words, it's bell-shaped or bell-curved. All right, let's finish talking for this section with outliers. So outlier, what is an outlier? That's where you have an extreme value when compared to all the other data. Okay, it could be extreme in either direction. It could be way bigger than the other data. It could be way smaller than the rest of the other data. There are ways to do this. We don't talk about that. We just kind of do it visually in here in this course as an introductory course. But let's look at this set of data. You know, it's probably difficult to look at this list and identify any extreme or outliers here. But if you put this on a histogram, you'd probably have a much easier time doing that. So let me pull up the visual of this as a histogram. Now hopefully you can see here with this histogram on the data that there's just that number 18. There's only one of those scores, right? There was one of these scores in the 40 to 49 range, one of those here, but these other ones are all kind of together over here, bunched up, if you will. This is your outlier, right? So it's an extreme value, kind of away from the most of the data there. That's referred to as an outlier. And that's the end of section 10.3. I'm going to cut off the video here. Thanks so much for taking notes, watching. See you next time.